Hello there, this is lab number 3 titled The Law of Reflection. We know that the light is characterized by a dual nature. It can be considered either a wave or a particle, and there's a whole bunch of different phenomena that can be explained only if we are looking at the light as a wave, one being the reflection. So this is an important phenomenon that can also be described and quantified using so-called the law of reflection. That is the topic of this lab. We will also learn that light interacts with the medium, with the matter, and one of the ways of interaction of the light with the matter is through so-called reflection. So the outcome of this lab is to describe that phenomenon, to observe it, to state the law of reflection and do a quantification, and finally to demonstrate and experimentally verify the law of reflection through a few experiments that will be part of this lab. The equipment to be used in this lab consists of a laser diode module. I'm using here a red laser diode module. You can use any other class 1 laser. And then we're also going to use two mirrors that are mounted onto these two wooden blocks. We are going to use the protractor, a pencil, and a white sheet of paper. So to complete this lab, we taped down the white sheet of paper on the workbench, and we also positioned our laser pointer. We taped it down to hold it steady at a specific location along the middle of the white sheet of paper. And as a next step, we are going to put the mirror that's been mounted on a wooden block on the path of the beam. And you can see when I am turning around this wooden block, you can see that we are producing the reflection here off of the mirror, and that the angle or direction of the reflected light ray is changing. So we are going to position this mirror at a specific angle, about maybe 45 degrees, and then we are going to trace the path of the incident beam and the reflected beam, and we are going to calculate the incident or measure incident and reflected angle and see if a law of reflection holds. The next step is to establish the footprint of the mirror. So here's the front surface of the mirror that we are going to mark with our pencil, and then we are also going to use our pencil to mark a few dots along the beam path. So the way to do that is to take the pencil, move it back and forth until we find the path of the beam, and then every time we find the path of the beam, we can mark the dot on a white sheet of paper. So we're going to make a few dots here to establish the incident light ray, and then also over on the other side we're going to do the same with the path of the reflected beam. Once you mark the two light rays, the incident one and the reflected one, and also after you mark the front surface of the mirror, you can remove the mirror and you can also remove the laser pointer to provide for more space for the rest of the lab. The next step is to trace the path of the two beams, the two rays, one being an incident one and one being a reflected one. We're going to do that by connecting the marked dots on a white sheet of paper. So the first one that we are going to do is going to be the incident light ray. So this is our incident light ray. And then over on the other side we have a reflected light ray that we are also going to trace. To determine the angles important in reflection, we are going to first construct the reference line. If you review the theory related to the reflection of light, you know that we have to establish axis that is perpendicular to the surface of the reflection. So in our case, this is the surface of a reflection, and at the point where reflection took place, which is going to be this point here, we're going to label it A. At that point, we have to establish the axis that's perpendicular to the surface of reflection. So we are going to use the protractor. We are positioning the origin of the protractor at the origin of our angles, or point A. And then over on the other side, we are going to look at the 90-degree mark, which is going to establish a line or axis that's perpendicular to the surface of reflection. And then we are going to connect the point A and our mark to establish the reference line. Now we can observe two angles here. The first angle is the angle that incident light ray makes with the reference axis. So that is going to be this angle here. We are going to label it theta 1 or theta incident. And then over on the other side we have a reflected light ray and the reference axis. So the angle that reflected light ray makes with the reference axis is called the reflected angle, and we are going to label it theta 2 or theta reflected. We are now going to measure these two angles. So we are going to start with the incident angle. We are going to use the protractor, so we are going to align the reference line on the protractor with the reference axis, position the origin of the protractor at the origin of the angle, and then measure it. So if we're looking at the scale that starts at 0, so we have 0, 10, 20, 30, about 35 degrees. So our theta incident is going to be equal to 35 degrees. We are going to do the same over on the other side. So we are going to turn the protractor, align it with the axis. So again, the origin of the protractor is aligned with the origin of the angle. We have a reference or 0 degree line on the protractor that's aligned with our axis. And then again, you have two scales here. You want to pick the scale that starts with a 0, not the one that goes with 180, 170. So 0, 10, 20, 30 degrees, and then 31, 32, 3, 4, 5. So 35 degrees. So our reflected angle is 35 degrees. What you can immediately observe here is that incident angle is equal to the reflected angle, and that's exactly what the law of reflection states. The law of reflection states that the incident angle and the reflected angle are identical. Moving on to the second part of the lab, we have established a little more complex type of optical system here. As you can see, we are using a few different devices, so we are going to dim the light in the room and then explain what this optical system consists of and how it works. In this second part of the lab, we have created a simple optical system that consists of light source, our laser diode module, and then also of two mirrors. And you can see here how we can manipulate the light in the sense that we are changing its direction. So we are letting the light hit the first mirror and then reflect off of the first mirror in a specific direction, being directed towards the second mirror, and then the second mirror you have another secondary reflection where the light is basically bounced back off parallel to the incident light ray. Now your task is to analyze this whole, to repeat this whole experiment, trace the light rays, the incident and primary reflected and secondary reflected, confirm that a law of reflection holds at each of the two mirror surfaces by creating the reference axis and measuring incident and reflected angle on one side and incident and reflected angle on the other side. And finally, to give some thought about where this could be applied, what would be specific types of devices or applications of this type of optical system that may consist of two or more mirrors.